Hello everyone. We'll start today's session shortly. So till the participants join in, could you quickly confirm if I'm audible? You can type a yes in the chat box. Thanks, Nikhil, for confirming. Just couple more minutes and then we can start today's session. Thanks, Ajay. Yep. Yeah. Hello everyone and welcome to today's fascinating webinar, which is Decoding AI Agents. So how they think, learn and transform the world. So I would say get ready for a deep dive into the world of AI agents, the intelligent systems that are revolutionizing industries and reshaping our everyday lives. So in today's session, we'll explore how these AI agents process data and make these intelligent decisions and the science behind their learning mechanisms, real world applications, and also the societal impact of AI agents as they become more integrated into our world. So, whether you are an AI enthusiast or tech professional or just curious about the future of AI, this session will give you a valuable insights into, how AI agents think and how they evolve and influence the world around us. And our speaker for today is Rushikesh Meharwade, the Vice President of Data Science at Motilal Oswal. Rushikesh is an accomplished data scientist with over a decade of experience, in performance testing, application monitoring, and Java tuning. His expertise spans across NLP, which is natural language processing, machine learning, and mentoring professionals in the tech industry like us. Beyond his, corporate experience, he's also very passionate about educating the next generation of AI professionals. He has also collaborated with top edtech platforms and worked with industry leaders like Capgemini and Renault Nissan. So his, deep industry knowledge combined with his passion for teaching makes him the perfect guy to answer all your questions about the exciting field of AI and ML, which is artificial intelligence and machine learning. And remember, this session is interactive, so please feel free to drop your questions in the chat or in the Q&A tab as we go along. Our goal is to ensure that you leave today's session with all the information you need to, take action and step confidently into the future of AI. And also, please remember, no question is too big or too small. Ask as many questions as you would like. So, without further ado, let's, get ready to explore. Let's dive into the world of AI agents. Uh, Rishikesh, over to you. Yeah, thank you.
Thanks a lot, guys. Thanks a lot, Lakshana. Hey, hi, guys. Good evening. I hope you all are able to hear me. Can you just please say yes or no in the chat so it will help me to understand I'm audible? Am I audible uh, loud and clear? Great, great. Thanks, guys. Thanks for your response. Good evening and welcome to the session on decoding the AI agents, which is a very trending topic that you may get to hear across different channels, different environments, everywhere. This thing is right now making a lot of creating a lot of boom. Uh, so many applications, people are talking about it. Many people are exploring things. I'm sorry, like I have a bit of a cough, so you may hear this thing in between. Yeah, great. So just to add, my name is Rushikesh Meharwade. I work as a VP of Data Science, and I have around 13 years of experience. Out of this, half of it has been in the testing domain, performance testing, performance analytics related to the production systems, load testing, tuning the systems. So it used to be a very different type of work than what I'm right now, the half of it. But we used to deal with a lot of data. Sorry. So there used to be a lot of data around like 2015, 16. We were working with a good chunk of data. And then there was also discussion around big data engineering, big data, machine learning, data science, sexiest job of 2021st. So all those things were there, and I got into this field of data science. With great learning, there were few programs at that time. Like one of the program was business analytics, business intelligence, Babi. It was called. Nowadays, it is called something different. Uh, but with that, like part time, I got into this world of AI, and after that, this whole field is on fire. I would say every year there are just something or the other which keeps on popping up, and this field is like it's on a hot fire. Every year there is something new from from the moment I started into this. Every year we get to see, okay, deep learning is coming, transformers are coming, bird-based models are coming, uh, vision-based models are coming, LLM models came. So this whole journey, every year something is crazy. So with that, I got started into different roles. So my major, I have been majorly into the finance field. Uh, one of the stints was with Motilal Morningstar, Motilal Oswal. So I've been dealing with a lot of different type of data, tabular data, image data, text data, recommendation systems, personalization, now LLMs, agents, so all of it. Okay, great. So that was a good brief about me. Now let's get started about the today's topic. So agentic AI. Now, uh, so we will go through the brief history of it. Before we start, I would like to know what you guys think of AI. What is AI as per you? So if you can just put your response over the chat, that would be great. So I want to know what is AI as per you? Responses over the chat will be very helpful. Yeah, please put it over the chat. I would say, like, what is AI as per you? What does it mean? Anybody who'd like to add? Okay, cool. So let me go ahead and add to it. So, okay, one response I can see. Sandesh says AI means making computers think like human to provide answers for queries. Okay, great, Sandesh. That's a good response. Under the works. Awesome. Anybody else would like to add? Machines which can think on its own as it was told early. Okay, Ramaswamy, that's a very good answer. Sandesh Ramaswamy, cool. Anybody else would like to add what is AI? Okay, AI is a system generated, AI is a system generating things in order to reduce the human effort. Okay, so you are more in terms of the generative AI, but yeah, very close. Purnima says machines which performs tasks like humans. Okay, great. AI means making computers to capable to do things like humans. Great, pretty good, guys. So, see these two terms, artificial intelligence. We as a humans, as a species have evolved so much as compared to the other animals. All because of the intelligence that we have, which is coming from this brain that we all have. And scientists have been trying to uh, replicate it from a good old times. From a good old times, scientists have been trying to say that, okay, the intelligence that we humans have, how do we give it to the machines? So that machines can start doing certain works that we do, and we get free from mundane tasks, and we get to do some work which is something interesting or something that is like more productive for us. And it doesn't mean when AI starts doing our job, we humans will lose things. It's always that humans are going to be working on something bigger, something more productive. That is always going to be there, and history has shown us that there have been uh, different type of innovations that have happened over the last 100 years. Not just 100 but many, but over the last 100 years there have been so much of differences in terms of the innovation, in terms of the technology, the different industrial eras. So all of this, so much has happened, and what we are doing is we are able to always take a next step and work on things which are beyond what we used to do. So this AI is helping us to so as this machine starts taking small amount of human intelligence one by one, we start going to the next level. And then again, we want humans to again mimic us. Again, we go next level. Again, we want machines to mimic us. Again, we go next level. So those kind of things are there in the loop. Okay, so great. Let's start with the agents. So agents are basically systems which are autonomous in a way. Now, any agent is like someone who is doing things on behalf of you. Like any agent we call in our locality that okay, he's an agent. Or what does it mean is he's going to represent you and do certain things on behalf of you. Now here we are talking about AI agents. These AI agents are machine-based, computer-based agents which can do things which you do, mimic you, and take some smart decisions on behalf of you. They understand the environment very well. They understand the knowledge, the environment, what kind of actions to take, how to do the step-by-step actions. Sorry. So how to do the step-by-step actions, how to communicate between multiple different agents, and then get the responses from each other. Every agent could be something different. And then these agents are communicating with each other to come up with some great outcome from all of this. So, in all, these are basically autonomous entities. And the very important thing is they are going to learn from the environments. So, every agent we can think of it as some kind of an environment they are put into. We will come to more examples around that. They are making the decisions and perform the actions to achieve certain goals. Every agent will have certain goals associated with it. Okay, so for example, now there are a lot of different agents, but let's say one agent could be just research a topic and write an article on. Okay, if we say research on a topic and then write an blog on it. So what will happen is one will be a research agent. The goal of the research agent is just simply to take this as a query. The topic will be given to it, and its role is just to research from the online. It just go through multiple different websites, just keep on crawling the data. It knows which websites to crawl, which websites not to crawl, and then get the appropriate content. Then second is the writing agent. This writing agent, this research agent is going to feed the output to the writing agent, whatever it is going to collect. And then this writing agent is going to use this context information and write the summarized version of blog from all of this content. And then there could also be a different type of communication that can happen. For example, there could be one more agent, which is a validator agent. Okay, based on the given topic, this validator agent, the writing agent will give the output to validator agent. It will validate and it will see if everything about that topic is already captured or not. If not, it will say that okay, this topic is missing to uh, the research agent. The research agent will also add that topic and bring the content for that. And again, it will pass on to writer agent. So this kind of thing will keep on happening till we have this review agent saying that okay, everything is good, we can go ahead. Then there'll be agent who will just going to publish this over the internet. So things like this, different agent with very specific goal. One agent is just doing research, one agent is just going to write, one agent is just going to do review, one agent is just going to publish. So these agents have a very specific goals associated with them. They are just going to do those atomic goals. Atomic means there will be like small tasks you assign to them, and they can take care of that task. So that's the whole crux of it. And these agents, uh, like, are designed to simulate things the way we humans do. Right? The main goal of this AI is to create a human-like intelligence, and that's why the AI-based agents are designed in such a way that they can make decisions which are similar to the way we humans make those decisions. And this allows us to solve some really complex problems. So now this research-based architecture, which I mentioned just now, this kind of thing for humans requires a good amount of time. But this agents can do it pretty well, like to a good extent. May not be a very complex blog it can write, but like small blogs where you need some kind of content, they can work and do the thing. Similarly, there could be financial analyst agents where if there could be multiple agents who are doing a different type of activity. One could be just understanding balance sheet, one could be just understanding income statement, one could be just understanding the cash flows, and then they all pass their analysis to one more agent. This agent will just aggregate everything, see if things are good out of it, and then take it further. So, like this, in a different type of situations, we can create agents which can mimic or create a team that will take care of completing that task. Then the as part of AI, like any AI system, when we say intelligence, now intelligence is all about how do we learn from the mistakes. So here also we say that okay, from the experiences, how do we learn again? And next time we try to reduce that error. So as we said, if the writing agent makes any mistakes, there will be agent which will take care that okay there is something wrong, and again it will try to correct everything. So there is a learning we have defined inside this where it will understand, learn, make the tweaking, and again things will continue thereafter. Okay, so learning is like any machine learning, artificial intelligence, the systems, deep learning, you name it, but all of the systems, the core goal is how do we learn, how do we learn from the mistakes and update the world knowledge that we have, and then use it again further for a next stage where this thing won't repeat and we are able to solve it. Let me just go through the questions I see. I'm trying to make an AI model to give accurate options tuning signal that exists already. Certainly, that's a good thing if you're able to do that. I think there are many people who are trying to do it, but it all depends on the performance that you're able to achieve. So, this thing many people are trying, but all comes down to what kind of performance you are able to get with that. Have you given the agents only split work and provide weights? So, weights is something different with the LLM based agents. We don't get any weights. These LLM-based agents are more of a prompting structures where they will respond in the text format. So your input is text, your output is text. In between, they can also access multiple tools like internet, your database, your company documents. So all of those could be a part of it. They interact with all of it and get the data and create a final summary out of it. Great, cool. Let's go ahead. See, the key characteristics of these agents is their autonomy. And that's why we all are going for that. If it was a manual, then no use of it. But they're autonomous. May not be for a very complex task, but at least for simple tasks, we can create the autonomous systems which can achieve certain goals. And then they can perceive. They can perceive things through the sensor, through the different channels, like we call tools in LLM-based systems, where they get connected to different surroundings. It could be a database, it could be your document store, it could be the internet, uh, everything included, all of it can perceive and then make a decision. If you ask that, okay, for certain client, you're asking to make certain analytics. So this agent will take care that, okay, when you're passing a client, it knows, okay, which table to access for the client details, and then which table to access maybe for further analytics thing. So it can capture that data, build the queries by its own, query that data, and then do some reporting through it. So like this, some architecture of uh, agents can be created, which was very tricky 1 year back. So before to 1 year back, creating this kind of systems was not easy, but agentic systems allows this kind of thing. You may say that, okay, what is different from general prompting versus agents? So the main thing is with general prompting, you have a very general model. You have a very general model that can make mistakes because it is general in nature. It just sees everything in a very general way. But with agents, what really happens is you are giving them a specific role. You say that, okay, you are a marketing specialist, you are a content creation specialist, you are a publishing specialist, you are a writing specialist. Now, when you give it a very specific role, this autonomous systems will only work on that goal. It will not go beyond that. So that is the interesting part of it. Okay. Then there is a good decision making. They can, based on the knowledge that they have gained from the LLM fine tuning, they can do a very better decision making. Nowadays, there are reasoning models. Now, reasoning models, like how many of you have heard of reasoning model in examples? Now, there are these models called as reasoning models. Like anybody knows? So if you guys are using ChatGPT, you will know what different reasoning models are available. There was a one recent model that made a lot of hype about its existence, and that also has a reasoning model. Anybody here would like to add? Great. Yes, yes. So that is DeepSeek. Uh, we also have this O series models from OpenAI. Okay, the O1. So this kind of models which are more reasoning based. Like even before answering your question, they have to think. It will list down the steps. It will try to think on its own like a simple scratch pad. It will just try to jot down things and then create its own proper steps and then take a proper action after that. So these reasoning models are very interesting. So they allow us to do a very good decision making from like whatever action we are doing. So O-series models, DeepSeek R1, Gemini has thinking models. So like this, every model has some kind of a reasoning variation. All of these are coming with the reasoning variations. Okay. So now in terms of overall history of those models, AI as a word has been there from 1950s. Okay, 1950s people have been talking about artificial intelligence, but the only thing is the original definition of the AI has transformed a lot over the 75 years. So when in 1950 to 1960, when people came up with this artificial intelligence, a lot of scientists who gathered together, they thought for 2 to 3 days, I think 3, 4 days, they did a conference where everyone together thought for uh, like what could be the next step, how do we create intelligence. So they're like this AI as a word came in and people started to create their own groups to take it further. So there were things like the focus was okay, how do we mimic the human thought, human intelligence, human actions? How do we do that? So they came up with some basic structures at that time. Not much of automation, but they came up with the simple structures. There was a Turing test, which basically says that if there is autonomous system, so it's saying that okay, in a room near to you, there are two people talking and uh, the communication that they're doing, if you're not able to distinguish who's machine and who's robot, so out of those two, one is a machine, one is a robot. But when you're listening, you can't distinguish like who is machine and who is robot. So there it passes a Turing test. That's a Turing test. And nowadays, in terms of audio, we have to a good extent very close to achieving the Turing test in the audio. Well, the system generated audio in nowadays, there are many good models. Listening to that, you won't be able to distinguish whether it's a machine or it's a human. So those kind of good models are available now. And then they also came up with the symbolic AI, which is more of like representing some symbol-based representation. So at that time, not much of implementation, but more of thinking process, creating papers that okay, how this whole AI should go ahead. And then 1970s to 1980s, this era of expert systems. See, at that point, the machines, computer itself are very new. Creating complex things were not possible. But people were even like, for nowadays, like when we say if condition, in programming, we have this if else kind of a structure. People who have programming background, we have this if else structure, which says, okay, if this condition is meeting, you do this action, else you do this action. So even creating this kind of a things were treated as AI. So because it was a very early stage for this. So it was more based on the rule-based decision making. So there are many rules, and based on the rule, if things happen, you make a decision. If again a different rule, the things will happen in a different way. Like that, there are many rules built here. So they used to call them as the expert system. Nowadays, the definition of expert would be very different. But at that time, they used to call them as expert system, but no learning capability. It was all hard-coded rules. Once you define it, if you want to make any changes, you have to again go through the whole process and do the redeployment. And it was very rigid structure. Once you have defined that, okay, if CIBIL score is greater than 750, then you give a loan or the interest rate would be this. And if CIBIL score is between this and this, you say that, okay, interest rate is this, the probability of that person getting a loan is this. So these things are very rigid. They are going to be fixed. Any changes you want to make, you have to just rethink or reprogram everything. Then in 1990s, the era of machine learning was there. A good hype also was there around machine learning at that time, where people were able to create a good models. There were many different algorithms which came in at that time, like neural networks and all. Also, people started to build at that point random forest-like things, and many different models came in at that point as a rise in the machine learning. But like neural network, reinforcement learning, all of this started recently. Like there was a uh, good award given to the people who initiated this word reinforcement learning. Recently, like 1 week or 1.5 week back, people who started with this term reinforcement learning, they got a good recognition globally for their contribution to the reinforcement learning or AI field. So these things were invented in like 1990s. But the biggest challenge at that point was there was no data. Like data was very limited, not many good storage options were present, uh, no good options around storing the data or to utilize it. So not much focus was there in terms of storing the data. So algorithms were there, but these algorithms can't learn without the data. So that's where this thing got stopped for good many years. Within the era of 2000s, where big data and computational power started taking speed up. So all this ML world was sleeping for some time. When the big data era started, MIS, big data, everything, people started to store the data to bring some interesting patterns out of it. At that time, even like storing this data and you try to identify some few patterns by doing a pattern mining. So there were simple pattern mining algorithms present which used to go through your data and bring out some patterns out of it. So people started to store data, do analysis on that. So that all started. And after a few years, as people started storing this data, there was also good improvement in terms of CPU power, memory power, all of it also started growing good. Then, so because of all this, there was the data, there were the algorithms before to this which were developed, and then from here the compute power and big data started working. So there were some advanced enhancement that started happening in terms of NLP, computer vision, autonomous systems, uh, AI agents, all of it as a reinforcement learning part, all of it started to become a good research interest. Then around 2010, a lot more interesting thing happened around the deep learning. So 2010 to 2015, there is a good research that happened in terms of the neural networks. Even GPUs as a hardware compute got popular because GPUs like were initially started for the gaming industry, but people found out that GPUs can also be used for building the deep learning based models, the neural network based models, because it has this internal structure that allows very good matrix manipulation approaches. And deep learning requires a lot of matrix manipulations. So that was a core thing. And lot of interesting thing happens around convolutional neural networks, uh, the RNNs. So all of these models like LSTM, recurrent neural networks, all of this started to take a big jumps in terms of the outputs and even the industry usage. So many image recognition, image classification models, text classification models, translation, this kind of application, language translation, and all got a good edge. And then trying to also put it inside the IoT based, edge based systems. So this whole era then focused more on the deep learning revolution, which also brought in the transformer based model. So all of it, the big jump happened in the industry when this model is called as a transformer model. With the paper, attention is all you need. So when that attention is all you need paper came in, there was this architecture which was proposed transformers. So these transformer models were like a data hungry models, data hungry and compute hungry also. So the more data you feed, the more compute you provide. These models can grow in size, but they can also engulf all that learning. Before to the transformer, the CNN, LSTM or RNN models, they were good, but after some point, they can't learn. Even if you start feeding it more data, more compute, they can't grow beyond some point. So there was some stagnation. But with transformer, that got broken. Now you can create big models with a lot of data. You keep pumping the data, and this model will start keep learning, keep learning. That's how these things called as a large language models got born. So, like the whole internet, you're using the data from the whole internet to fine tune this model or build this model. And even after like giving all of this, these models are like keep on learning. And these models internally are nothing but next word predictor models. They just try to identify what is the next word. So when you see the generation in the chat GPT, you see that okay, one by one words are coming. So these models are just learning what is the probability of every single word, um, given the input word, what is the probability of every single word. So highest probability word is picked as a next word. So these models are internally nothing but probabilistic models. We just identify what is the probability that given this input word, what is going to be my next word. Okay. Okay, cool. So now let's understand the importance of AI agents. So right now, AI agents are like this 2025 year is being called as era of AI agents. There are individual AI agents. There is a multi-agent architecture, like multiple agents collaborating together, individual agents working on independent tasks. So like this AI agent is being talked about. They can just transform a lot of things. In terms of automation, things are going to be very different as compared to the way we have been automating things till now. So it enables like a real-time decision making, and it also allows to learn based on the new challenges. Like it is able to adapt and again go on. So you must have heard about so all of these LLMs, they are trained with the two things. One is like a self fine-tuning, self-supervised learning, like where this models learn based on the given data. And then there is a reinforcement learning. So this reinforcement learning is also called as a reinforcement learning human feedback RLHF. So what it does is it tries to constrain the model to certain behavior. So that way they can learn continuously based on the feedback that you keep giving to it. They can learn. So one thing we already understood, they are auto good for automations. Agents handle like a repetitive, time-consuming task. Something that you're doing now, like even if it takes 1 minute, and like uh, that 1 minute, like you have to spend every day, like where you have to do some kind of a specific decision making. This AI agents can take good care of those things. Okay, allowing human workers to focus on strategic and more creative work. So this AI agent can tackle some repetitive work. They are scalable. Now, when we are saying like you can do that 1 minute work and do it every day, but let's say that 1 minute of time, if you can scale it, like many people want to do that 1 minute work, and this agent then can be used by multiple people for the scaling. Not just multiple people, even you want to automate that one minute task that you may be doing on a repetitive task, you just automate it across the scale and a lot of things can happen in a parallel way. So they can process a large amount of data and manage large scale operations and also enhance the efficiency across the different industries. It has a real-time decision making. You don't have to wait. All this model will take the chunk of data, will do its own decision making and provide an immediate feedback. You don't have to wait for a long time to get any kind of a response. So that's why it is being used in different applications like autonomous driving, robotics, financial trading, customer support, email support, health support. So all of these things, the the systems are being used. They are adaptable. They can learn. They can improve. Um, so that is the main nature of it. Then there is a personalization. So they can learn your behavior over the time. There is also a component called as a memory component. So whatever you are trying to interact with over the time, all of it can be learned as a memory, and this memory then will be used to answer your questions in a more personalized way. So LLMs, as you already know, will be responding in a different way to everyone. So based on the channel of uh, communication that you're having, like you have a one window open, you are asking like a multiple questions. It knows that whole question sequence. Sorry. So it knows that whole sequence of questions you are asking. It can memorize it and understand like what was the question that you had 5 questions before. What was the answer that was given? All of it can be considered to give a new response. So that's how it will. we can create some complex systems which can be more personalized to our needs. Uh, Before we go ahead, any questions? Do you guys have any questions? So please don't stop uh, for asking questions the moment you have it. These questions are to be put out immediately over the chat. You don't have to keep it in your mind. Just blurt it out. And whenever I get a time to see the questions, I'll see in between times and will be able to respond to it. But the moment you have it, please ask the questions. So Purnima, you can connect with the Great Learning team. They'll help you to understand, like, to get the PPT. Okay, great, great. Thanks, Purnima. Cool. So let's continue. Okay, I have a question. How we can build these types of AI agents, LangChain or any other good framework? See now, uh, there are many different frameworks which are there in the market. There is a Crew AI, there is a LangChain. So all of the different frameworks, they have some positives, they have some negatives in terms of the usage. So based on the application, we have to utilize the libraries. So LangChain is one thing that is good for learning, but in terms of production usage, there could be different type of libraries that you may have to use. Sandesh, that's a very Sandesh is asking your view on where AI will be scaled in next 10 years. I would say 10 years is a very far time that you are asking me. I don't even know what will happen in 1 year. It's difficult to predict right now the way things have been moving. How the next 10 years would be the very difficult part, I would say, but just like next 1 to 2 years, how the world is going to change, the way things have been built, how they will change, how we are interacting with the computers, how they are going, that is going to change. So, lot more things are going to change, I would say. So, predicting that is uh, difficult. Yeah, AI memorizes questions asked. What is the hardware used to make this possible? In what ways GPUs are used for AI? Okay, Thyaga Raja. See, AI memorizes questions asked. It's like the framework that we use to build this. They allow us to maintain this memory. Okay, but there is a limit. You can't have an infinite amount of memory that you can provide to it. If you want to provide some knowledge, there is a model fine tuning. So, model fine tuning, we can embed a custom domain data knowledge into this models by doing the fine tuning of this models. But otherwise, there are other ways by which we can also integrate this knowledge inside this models. Okay. So in what way GPUs are used for AI? See, GPUs plays a very important role in terms of the compute. So CPUs are limited in terms of the parallel compute that they can achieve. CPUs can't do a lot of parallel compute. They are restrained by the general usage that we have. Whereas for a game, if the game is all about the pixels as a matrix, the whole screen that we see, right? The screen is nothing but the pixels. And through this, we get a pixel based matrix. So game was used to be like, how do we keep on manipulating this matrix of screen? So the GPU was that's why created separately to handle the screen related activities in a much faster way as compared to CPU. But then same thing also matrices we use in deep learning AI based systems. So there also we need a lot of matrix manipulations. That's why people started to utilize this GPUs for building things in a much faster way. And now the GPUs are like I think more than games they are being used for deep learning the systems. Okay, so that is the main thing. Like the same model you try to run on a CPU, the deep learning based model, and same model you try to run it on a GPU, the performance is going to be very different. Okay, CUDA cores make parallel processing easy. Absolutely right. So CUDA framework allows to code it in a way by which people can build things where they can parallelize these things. Okay, so CUDA is a SDK like support that NVIDIA has built where people can use it to code around this CUDA course. Great, great. Yes. Okay. So now, how does AI agent basically work? See, the main thing is one is this AI agent. See, we also as a humans, we are limited by what our senses provide us. That is like a one part of it. Like what we can see, what we can hear, what we can smell, what we can feel. All of that is our perception, what we can get from our environment. So that is like a very important data for us. Like any type of step that we take, any action we do, many of it depends on the surrounding environment that we are going through. If you take a simple example of autonomous car, okay, for autonomous car, the perception is going to be the surrounding cars, what it can see in the front, what it is there in the back end, what is there in the side. So it can just feel all of that. How many people are inside? What is the temperature currently? So all of that becomes the perception of this autonomous cars. So they gather the data, and the data could be coming from a lot more different type of devices, places. It can come from a lot of different ways. Then the second is reasoning. Once you have collected all this data, now what is the next step? Now see, if the car is moving at t is equal to 0, okay, t is equal to 0 times 0, you collect all the data and then so t0 you collect all the data and now you make a decision as what should be the next step. Like for example, when you are in the t0, there is a signal which is red, okay, and so next step would be you don't make any next step. So again, in the next step, you try to see whether the signal has converted. So the moment that signal gets to green, then you make a next step, that is you move in the forward direction. So reasoning allows us to make the decision that okay, based on the given data, what is the next step? Then the action. So as I said, decision is one thing. You say that okay, I will move next now, and then the action, where you actually move further. You actually take that action and do that performance. Now, when you have moved further, now you have gone from the signal to the next step. Now there is some other data. It could be like now you're trying to see when you're moving, which are the cars in surround to me. Is there any car that I may collide with, or is there something that turn that I have to take? So this is like a data. Then you think what is the next step you should do, and then you actually take that action. So either physically or digitally. Then robotic vacuum cleans like navigates room for efficient cleaning. They keep on moving and then take a decision whether there is any dust or any kind of things that it want to collect. It will go through that. Then at the end, it's a learning. So learning is like when that action was performed, whether things actually move. Like, see, even if your reasoning is saying that, okay, you should move, but there is a wall and you're trying to move ahead, but the learning says that you're not moving, you're stuck. Okay. Or, for example, when you have a red signal and you are taking an action that go ahead, and when you go ahead, there is a fine that you get or the penalty that you get, which says that, okay, when there is a red signal, you should not move. So next time when the system again takes this action, when it sees a red signal, it knows that okay, there is a penalty. Now I can't take this action of move. I have to do something different. So this kind of learning gets embedded in this systems. Okay. There are the different type of agents. There's a simple reflex based agents. Just they work based on the predefined rules. There are just simple rules. You say, for example, I talked about, we are saying, okay, CIBIL score is like the moment a user is coming to, let's say, an insurance company or a bank loan. You want to take a loan, the user has come, there is a agent. And that agent is not making any decision, it's just pure simple rules which say that okay, if your age is this, your CIBIL is this, you will get this much. If you're this, then you will not get this. So things like that which are very predefined. You are not making any kind of a decision on the given data. Model based reflex agents. So these are like some trained models that we try to create, and some learning gets embedded in these models. So maintain an internal model of the world to keep track of the unobserved aspects of the environment, which will make like more informed decisions. So you are trying to train it on certain data uh, to make it understand how to look into this problem. And when it goes in the real environment, it has learned the important characteristics of the problem. So even if a new situation arises, which it didn't know earlier how to respond, but it can do some decisioning based on whatever it has learned and then come up with the solution. So those are model-based reflex agents. Then there are goal-based agents where their task is to achieve that goal. So they'll keep on doing the action till they achieve a certain goal. They'll not stop till that goal is achieved. So they'll have some kind of a learning, or even they will keep on learning based on the action. For example, now if a car is given a goal of pass the signal, okay, and you define some kind of a reward and penalty, and you say that okay, if you're moving beyond the red signal, you get a penalty. If you stop for a red signal, you get a reward. So this goal of maintaining the reward is what the system will keep on doing. Okay, then utility based agents. It's like different actions to choose the one that maximizes the overall satisfaction or performance. So it will try to look at all the different possible actions that it can take, and then out of that action, it will pick the one that usually maximizes the overall performance of it. Then the learning agents, like they keep on learning from the environment and experience to improve their performance over time. Like robots could be good example where they will keep on observing their environment, take actions, and keep on learning from that action as whether this thing worked, the hand movement or something that it does, whether it has worked or it needs to do something different next time. And it doesn't have to be just a one type of agent. Your agent could be a combination of multiple of this, where you try to group together these things and build a one single agent. Then different ways to learn. One is the supervised learning. In the supervised learning, it is like you're giving an machine a data that you really want to understand the patterns for. For example, if you say whether a stock is going to move in 1 month or not, move in a positive direction in 1 month. Now, this is what you want to learn. Okay, given a certain stock parameters, okay, you may have got some different type of parameters from the stock like prices, volume, all other things. And then you're saying, okay, what will be the price 1 month after? So you want to learn what will be the price 1 month after. You are feeding it this data, which is just recently done. So now what will happen is your machine will keep on looking at the patterns that okay, when this is a price 1 month after, what was this other data look like? Again, for a different data set, it will again check okay, what was the data like? What was the data like? And it will create a pattern by itself. For example, if you give it a loan uh, whether to give a loan or not, this kind of problem statement, and you try to feed it with the historic data. You say that, okay, if the age is this, if the salary is this, if CIBIL is this, then this customer was a good customer for giving the loan. If the age again was a this different number, CIBIL was a different number, again different feature was a different thing, then the the customer was like this in paying his loan. Now the machine will try to learn the rules by itself. That's the goal of machine learning, where it will learn that okay, if the CIBIL is greater than this and this person has a salary of this person is more capable of paying the loan. These things we had to do manually beforehand. But with the supervised learning, this kind of things, by giving the data, these things systems can learn by themselves. Unsupervised learning is more of you do not have this goal. As I mentioned just now, there is no goal that you're trying to optimize for, but this is a in general case something like clustering. You have got a lot of different customers' data, and you want to understand which customers are similar to each other, which customers are different from each other. So this kind of thing is more treated as a unsupervised learning. Then the reinforcement learning, which is very different, where you do not have the data beforehand, but you want the system to learn from the given environment. You know what is a reward, you know what is a penalty. For example, if you guys have played Mario, like when you first start with Mario, you don't know anything about Mario. Okay, you don't know anything about Mario, but you start taking one by one steps. Now, one by one steps when you take, the first thing that comes is um, maybe a mushroom or the tortoise. So you don't know what to do with that. When you see it first time, you don't know what is the step that I should take when the mushroom or um, a turtle is coming. Should I bump into it? Should I jump? Should I go back? What should I do? So first time you don't do, you go straight. You identify that okay, when you touched it, the life went away. You're again starting from the scratch. So now you note it down that okay, if there is a tortoise, you go straight. That's the wrong thing to do. And next time again you come to that point. Now you know you should not be going straight. Something else you have to do. Either you jump, either you go back, something. Maybe you say back. But then again, nothing happened. You again get to know that okay, back is also not something I should do. So this kind of trial and error based learning across a big action space is what happens to the reinforcement learning. Okay, that's a high level picture of it, I would say. Then in terms of practical application, the general life cycle of this model look like data collection, pre-processing. You do model training after getting the data. Then you deploy these models in different environments. And then you keep monitoring these models and maintain them. Okay. Applications, as we discussed a lot, there are many different applications. The systems like can work with autonomous vehicles, different type of robots, personal assistants, the game-based AIs, financial trading, healthcare. So all of these are like a different type of applications. Now, just to give you about a brief about Great Learning, they are the India's leading edtech company for professionals and higher educations. They provide like a good completion rate, learner satisfactions, and the important program which is there is postgraduate program in AI and ML. It's a 12-month program. It has a very flexible structure, and it is also provided by like it also has a support with UT Austin, ranked number one program for like 5 different consecutive years. It provides a immersive experience for hands-on learning where you get to learn hands-on with the mentors, and it also provides a peer-to-peer learning. Okay, so you will also get to interact with faculty members who are renowned experts in the field. Okay, so you get foundational courses and also self-paced modules to go through it. Different type of domain exposure, lot of different tools which are used in the AML space is also part of it. Okay, different career transitions, and you can connect with the team if you want to know more about the program. And also, the team has shared a feedback link. Uh, just go through that link, provide your feedback. If you need any support, the team will reach out to you. So that's for the today's session. If you have any questions, please add to it. Thanks a lot, Sandesh.
Thank you so much, Rushikesh. It was a very insightful session and hope everyone's questions were answered. Thank you. And please take a moment to fill out the feedback form. You can post your questions there as well. Our team will get back to you regarding the program or anything. Just feel free to fill it. Thank you.
Thanks a lot, everyone. Thank you, guys. Have a great time. Bye.
Yeah. And others, I'll just wait for a couple more minutes. Please fill the feedback form. Cool and have a great evening. And please copy this link and fill the feedback form.